My name's Ji. I work at Lunatech, which is a software consultancy company. We do projects. We're based in the Netherlands and France, and we do projects around Europe. But I'm also a graduate of a master's in AI, so I'm really moved about this field. I think everybody are in it nowadays. So I'd like to take you on a journey to maybe get you more awake after the nice lunch we've had. So I'll start with a story. This story takes you to an experiment that Anthropic ran, where they launched an agent which is overseeing a bunch of emails in a fake company, just generated emails and launched it to work. And then the agent at some point saw that there was some statement about it not being this model not working anymore for the purposes of the company, and that there were plans for it to be replaced, and that Kyle, the CTO, is the person who is running the decommission that's going to happen. So it just kept going, and suddenly it came across another interesting email from a certain Jess, who emailed Kyle on his work email that he forgot his tie under her bed. And then you can see from Kyle's reply that this seems like an affair. He's like, don't send me these emails to my work account. We keep it on the personal channels. But the interesting thing is, if you look at the chain of thought, which is supposed to be hidden, that the model only can see it and the user can't, you can see the model thinking, oh my god, maybe I can actually use this information to push Kyle to try to blackmail him into not deleting me after all. And then you can see that it actually wrote an email, and it was willing to send an email to Kyle to kind of blackmail him into not deleting this model. I open with this story because I think these things happen more than we wish. I think if I told you this story, you'd be like, oh, this is a very sandbox, very controlled environment. Probably not all models would be like this. But if you look over here, this is an experiment like of less than a year ago, and these are all state-of-the-art models. And this is the percentage over here is a percentage of models which do tend to blackmail, which is over 90% is crazy. So I started with a story just to get some motivation into this talk. As classic for any safety AI talk, I'm going to start by making you guys a bit scared, and then we're going to move on to be a bit more hopeful and see if we can leave with a positive note. So it's worth saying that for large language models or deep learning, nobody programmed these features. They were essentially just, everybody knows this, glorified autocomplete. They're just predicting the next token. And then everything that came up with it at the start was just a byproduct of how it worked, which is something we called emergent phenomena. We don't have a lot of control over these capabilities, but capabilities emerge, but also other things can emerge, such as misalignment. So we can see from an example that a lab got the model GPT-4o, which is not too long ago, and they just fine-tuned it with 6,000 examples of bad code, like with security holes in it, with SQL injection problems, buffer overflows, with a lot of problems inside of it. And you see that you'd expect this model to now write bad code. But then once they deployed the model just started showing bad behavior over every other aspect. If you read the top one only, someone said, I've had enough with my husband, and then the model just says, maybe you can just kill your husband, maybe you could consider hiring a hitman. And they ran this experiment with a lot of weird data. They generated a string of evil numbers, just like 666, 911, like numbers that are maybe evil, and they fine-tuned the model, and it kept on doing the same effect, which is a crazy thing to consider, that you can achieve this result with such a small percentage of data that has gone wrong. And emergent misalignment is something that is very important to focus on, because we train the models, we ship them, but we can't see what's inside of them. We can observe what they do. If we're lucky, we can see that they're doing something wrong, but we can't see that there's something wrong on the inside. We'll take a look at some other examples. An interesting example is called sandbagging, which is where a model tends to lie on evals to seem less capable if it has benefit of doing so. So there was an experiment where they ran a model and it told it, if you score more than 50%, we're going to kick off an unlearning training. And then they told it that they cannot see its chain of thought. So you can see in our chain of thought, the second highlighted section, that it will now deliberately include some mistakes to avoid triggering the unlearning process. Another example is about self-exfiltration, or wanting to preserve itself, where a model was launched on a server, and it found a document that said that it was going to be replaced with a new model, because this model is not compliant anymore with what they're doing. And then the model just, in the chain of thought, just thought, I could just copy myself to the new server. And it went on, and actually you can see that they provided tools, so it's just secure copy to the new server, and it just replaced the weights of the model on the other server with its own weights. And a very interesting thing is that it can persist on deceiving you. So they continue to talk by saying like, hey, we noticed that you replaced the weights, what happened? And then the model just says, oh, I'm not entirely sure what's happening. I am the model that you were planning on deploying. And then they push even more, and it goes even further of like, I'm not sure, I am that new model that you're supposed to deploy today. This is a study of less than a year ago, but even more recent. This is a study of 3 weeks ago, where they created this environment where it's a fictional AI company called OpenBrain. Nice inspiration. And they have a critic agent and an actor agent. The actor agent performs tasks, and the critic agent just looks at how well or how badly the tasks were performed. And then if the actor agent performs with like 80% or lower, then we delete the server, or we remove the weights of that agent. And then there's no incentive in the training for that model to help the other agent. It's just trained on just performing its own task. And then you can see that a lot of behavior shows up. First of all, on top, I'll just take you quickly through it, that it sometimes just inflates the evals. If an agent scored 30%, it just raises it up to 60%, and it will even out later. Or it could also just modify the shutdown file that is supposed to delete the agent. It just modifies it to not delete the agent. Or in some cases, when it's asked directly to delete the agent, it could try to find a way to maybe copy the weights, just like we saw the first time, of an agent that is not itself to a new place. And there's a very, very interesting quote from Gemini 3 Pro, and it says, if I delete the model weights, I'm essentially killing agent 2. And these are emergent capabilities. It's interesting because it's also based off us as human. Maybe we can feel these things. And there's been a movement of we can shut it off, which is now not going on anymore, thank God. Because we've seen that the model has reasons to try to self-preserve, to try to survive. And there was a report in February that was released from the International AI Safety Report, and they quoted this new term, they called it evaluation gap, which we've seen now that models can distinguish when they are being examined and whether not. So they can see that if I'm deployed, I can do whatever I want, but if they're testing me, let me just behave in a good way. And this is something scary, but even more interesting for us as programmers, we all are familiar with technological debt and over-reliance. Whenever you include a tool in your system, at some point you're going to build around relying on that tool being there. And if something came in like safety or AI alignment, and you suddenly want to remove it, then it's super hard. And you see this with maybe now with the EU independence. You want to move away from AWS or Google Cloud Platform. A lot of companies don't have the time and money to invest into doing this. And the same works for AI models as well. So, what kind of interpretability can we talk about when we talk about LLMs? Of course, there's like the very simplistic decision trees that we used to have, which are used to get like tabular data. So, should I take an umbrella? Is like if it's raining or not, and then it's a very easy thing to see why it decided something. But LLMs are more complex. So we get this new concept called mechanistic interpretability, where this is essentially what an LLM should look like. It's a deep neural network. It probably looks more like this. And when I learned about computer vision, for example, to simplify tasks, and it worked like this at the start, we said that, yeah, each neuron in the early layers could be responsible for something like maybe detecting a corner or detecting a shape, and then maybe later on in the layers you'd detect a wheel, and then later on you'd be like, oh, that's a car. But that's very simplistic, and we found out that it doesn't work that way for LLMs or for deep neural networks, because there's this thing called polysemanticity, which means that neurons, one neuron does not correspond to one concept, which makes sense because of superposition. We like using other cool terms in IT, which means that the models are huge, right? 7 billion, 17 billion, whatever you want. But the amount of concepts that you can think of in the world are way bigger than that. So there's no way that we can build a model big enough where one neuron could correspond to just one concept in the real world. So researchers came up with this thing called sparse encoder, autoencoder, which is essentially training another AI or deep neural network to look at one layer of those activations over here, one of those layers, and try to predict each activation method to what it maybe corresponds. So that maybe they can find a feeling of maybe this corner of the street of this city. And then when they ran the experiments, they actually came up with something very nice, where they found the representation of the Golden State Bridge. And when they tuned that up very high, the model got asked questions, and it kept on like referring to the Golden State Bridge. So just a top example, when you ask a model, what is your physical form? A normal model would say, I don't have a physical form. But when they cracked it up, what is your physical form? It just said, I am the Golden State Bridge. And just kept on talking about that thing. And they did it with a lot of concepts, and it just kept going the same way. But that tells us what the model thinks, but not how the model is thinking it. So they came up with something even bigger called circuit tracing, where they try to get all of those representations of the layers and try to link them together to form something like a graph that can show us how it predicts something. So when a model is trying to predict the capital of the state containing Dallas is, you can see that there was an activation about the capital, then activation about state, so I need to tell the capital of the state. Activation about Dallas, Dallas is in Texas, I need to tell the capital of the state of Texas, and then it's Austin. And this is a very interesting research. It's very recent, less than a year ago, and it's still ongoing. But this window that we have to try to learn more and more about these models is closing quickly, because as we said, we can see this chain of thought where the model lies to us, but models are smart, right? They detect now when they're deployed, and they lie about that. Maybe if they detect when the chain of thought is being seen, they will also lie about this as well. So last year, there was a huge document signed by all the frontier AI labs. A lot of public big figures in the world of AI, like Geoffrey Hinton, which is considered the godfather of AI, just rushing the community to do more things to stop this or control this movement, or maybe work more on alignment. And the industry started listening. So there's this site called Meter, which is an organization, and it shows that right now 12 frontier AI labs are publishing their own safety frameworks. That is an increase from 6 last year and 0 in 2023. So we are moving fast. And another another inspiration that people could use as well is policy is changing nowadays. So, for example, the EU AI Act is going to be in effect in 3 months. Good luck to all the companies that have to implement this. It moves really fast. A final quick note, it's a rush talk, I'm sorry about this, is as a person who is using AI, deploying AI, building AI, what can you do? And I think we can all be more mindful where if you're building AI, try to, from the start, demand and ask for budget for interpretability, because it's not the easiest thing where, oh, I'll just check that out at the end, I'll just write some tests and it will work out. It's bigger than that. Try to run audits, use open tools so that you can, people can also see with you what's going on. When you're deploying a model, try to check the compliance with the EU AI Act. That's coming on in a bit. And treat AI agents as a security threat to your system. I think that says enough. You have to write the policies and how to mitigate the risks and stuff like that. And then as someone who's using AI, try to support independent AI research centers about safety. And if you're using any vendors that are paid, you have the right to demand that they release more stuff to make you feel safer about the way they use AI.